Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good evening, guys. So, can you see my slide here?
Can sir, can.
Can eh? So today just overview. Okay, overview of fuzzy logics. Okay. So on this today we just focus on the overview. What is the fuzzy? Yeah, definition of fuzzy. Okay, the application of fuzzy, the advantages of fuzzy, and and then also we just try cover until the basic fuzzy lah, the fundamental the component inside the fuzzy logics. Okay. All right. So the objective of this topic will be to get an overview what is the fuzzy system lah. Okay, what is the fuzzy, and then to understand the concept of fuzzy logics, and also learn some application of fuzzy logic control lah. Okay, so the learning objective, learning outcome for this topic for the fuzzy logics. Okay, so this is a definition of fuzzy. Okay, the word fuzzy is mean blur. Okay, blur or in Malay we call a kabo. Okay, so fuzzy logic is the logic kabo lah in Malay, or sama or kurang jelas lah. So that's why yes, I have to improve. Okay, so this is a definition of fuzzy. Fuzzy is mean blur. In English is blur. Okay, but still in the logic. Okay, that's why we call the logic fuzzy logics. Okay. So some important point to note, okay, fuzziness is the deterministic uncertainty. All right, so the fuzziness is connected to the degree which event occur rather than the likelihood of the occurrence, similar like probability. Okay, so you can see the one, this one, for example, the degree to which the person is young is Razi event rather than random event lah. Okay, for example, okay, how we set the range for the young. Okay, so everybody will have their perception. Okay, their perception how definition of young. Okay, for example, like okay, for example me, okay, young, maybe I can set from 18 to 30. All right, so maybe you can set as the 20 to 30, up to you. That's why the fuzzy logic is the based on your logic. Okay, based on our logic. Okay, for example, when we design the traffic light, okay, when we design traffic light using the fuzzy logics, okay, so when we want to to set the green light, okay, the green light for the green light for the traffic light, for example, if we have the only one car waiting for the traffic light, so how many time you want to set? Okay, for example, 10 second. Okay, so you can set based on your logic. Okay, 10 second is enough. Okay, but maybe some of you it's not enough. Okay, 10 second. Maybe you need maybe you can set as the 50 second or 20 seconds. Up to you. This one based on our logic, based on our observation, based on our experiment. Based on our experience, experiment. Okay, that's why we call the fuzzy, but still in logic. That's why when we combine, we call the fuzzy logic. Okay, that means when we decide this decision based on our logic. Okay, based on your logic, because your design your fuzzy logic. Okay, based on your study, based on your experiment, based on your evolution. That's why you can set. Okay, you can set everything in your range. For example, here the example is to set the range for young. Okay, if you want to set the young, okay, for example, if you can set also 18 to 30. Okay, some of you can set as 20 to 30, or some of you can set as 10 to 30. It's okay, that is also correct. Okay, that's why, okay, if you design your FYP using the fuzzy logic, the panel cannot blame your fuzzy is wrong, because this design based on your fuzzy is based on your observation, based on your study. That's why panel cannot blame your fuzzy is not good, or is not correct. Okay, this design based on your study. Okay, based on your design, based on your logic. Okay, all right. For example, like when you want to design the traffic light. Okay, traffic light. Okay, that's why if we have only one waiting car in the traffic light, if you set 60 seconds, okay, so it's not logic. Okay, only one car. So that's why we need the logic, based on logic. Maybe we just set 10 seconds, okay, 10 seconds only. or 20 seconds, depends. If you set the 60 second, but only one car, it's not logic lah. That's why we call the fuzzy logic based on our logic lah. Okay. Alright. So how does fuzzy logic resemble human intelligence lah? How fuzzy logic imitates human intelligence? Okay. From the clustering classifications. Okay. So it reflects some form of the human reasoning process. Okay, for example, hypothetical rules, okay, inferencing and logic reasoning lah. So normally we use this one. If hot, then don't touch lah. Okay, for example, like right now, So if the cases of COVID-19 will be increased, so then the online will be happen lah. The online class will be happen, or we have longer MCO. Okay, we can set as the based on our logic lah. For example, if the case is every day will increase, the COVID-19 will be increased, then the MCO will be longer lah, something like that. Okay, so it can handle a certain level of imprecision and uncertainty. Okay, this is how fuzzy logic resembles human intelligence lah. Normally based on our logic lah. Okay, for example, if this one is, for example, if today is rain, okay, so then no class. Okay, for example, like that lah. Okay, we do based on our logic. Okay, our logic. Okay, so this is some example of linguistic imprecision, unusual and real codes. Okay, for example, if someone asks you about what was the weather like yesterday, so normally we can say as this one. Oh, it was very humid and really hot. Okay, we don't say as, oh, it was rainy with 98% humidity and hot with the temperature of 35.5 degrees. Not like that. So normally we just said very humid and really hot. Okay, that is the real life code lah. So that's why fuzzy imitate. How the fuzzy want to imitate, for example, like very humid. So fuzzy will be set the range. Okay, set the range for the very humid or really hot. So we can set on the fuzzy. We can set what the range for the temperature of for really hot. Okay, maybe we can set as 30 40 degrees as the for the really hot. Okay, that's why normally the fuzzy logic based on the real life codes okay, real life codes. Okay, they don't use the specifics. For example, linguistic imprecision very complicated. Okay, set as 98 humidity. So how we measure the 98% humidity? That's the sensor lah. Or we have another one. So the temperature of 35.5. So normally we can say as today is really hot. Okay, something like that. So fuzzy is follow like human real life code lah. For example, very humid and really hot. So how we can set. Okay, so for example, really hot. So you want to set from this range based on your observation lah. Okay, for example, like this. Okay. So normally when you are near at the junction, okay, so then start braking slowly. All right. So normally we can set like this. When you are near. So we can set near. What is the range for near? So maybe 1 to 10 meter. Okay, from the junction. All right, and then also we can set the braking slowly. So how we set the range of slowly? Maybe from 60% to 70% pedal level. Okay, that is the range for slowly. So that means we put some linguistic imposition to the human decision. For example, slowly we can set the range. Okay, slowly, okay, we can set, for example, like from 50% to 70% pedal level or near. Okay, we set near. So how we we can set the range for the near. For example, 1 to 10 meter. Okay, 1 to 10 meter in the range near. Okay, far maybe, for example, far maybe we can set 50 meter to 100 meter, for example, like that. Okay, so based on our assumption, based on our study lah. Okay, this is some example of the fuzzy logic. So you can see this is among many applications, fuzzy logic is the most successful in the control. right? So that's why you can see a lot of our electrical appliances that use the fuzzy logic. For example, like I will show last class, we have the rice cooker, okay? We have the fridge, okay? We have the washing machine, they use the fuzzy logic lah. Okay, a lot of electrical appliance that use the fuzzy logics, okay, control. Okay, so this is system for fuzzy logic lah, fuzzy logic control. Okay, the first slide you can see is similar like basic control system. Okay, so we have similar, we have the inputs and outputs, okay, but before this you are studying in the PID, now we go for fuzzy, okay, we go for fuzzy logic control. Okay, so inside the fuzzy logic we have the component lah. After this we go for the component inside the fuzzy. Okay, actually the fuzzy logic we have 4 basic component. Okay, you can see this one. So actually we have fuzzification or fuzzifier, and then we have the inference engine, we have the knowledge base, and we have the defuzzification lah. So this one will be inside the fuzzy logic lah. We have 4 main component for the fuzzy logics. Okay, and then we have go for the process, and then we have the feedback lah. Feedback with based on our sensor. Okay, it's similar like our basic subject, our basic subject for the control system. Okay, we just change so they on this part lah, on the controller part. So we change to the fuzzy logic. So this is one technique in the AI. So another one will be on the neural network lah. So now we focus on the fuzzy logic. So we change this controller from conventional controller, PID controller, to fuzzy logic controller lah, right? So this is that I mentioned to you is the component lah, component component, or sometimes we call the fuzzy logic architecture lah. Okay, so you can see this one. Okay, the first component is the fuzzifier, or we can call as the fuzzification lah. Okay, the fuzzification is the process from convert from the crypt set to the fuzzy set lah. Alright, so that is the function of the fuzzification, right? So and then the inference engine. Okay, the inference engine is to do the decision. Okay, actually on the inference engine we have normally we have 2 types. Okay, we have 2 types lah. On the cover will be on our class. We have the Mamdani, and another one will be Laksen. Okay, but if you go for the MATLAB, okay, MATLAB we just another 2 technique. One is the Mamdani, and another one will be Sugino. All right, but for this class I will try to cover the both lah. Okay, we will try to cover the not both, the 3 inference engine. There is Mamdani, okay, Sugino, and another one is the Laksen. Okay, but in our class, so I will explain on the Mamdani and Laksen lah. Okay, maybe on the when we design on the fuzzy logics using the MATLAB, so I will show okay what is the advantages, okay, using the Mamdani, Sugino, and so on. Okay, but on the MATLAB we have only 2 inference engine lah. There is Mamdani and Sugino, right? And then on the knowledge base, so knowledge base we have to set the rules. Okay, inside the knowledge base we have set the rule lah. So, I mentioned to you, for example, like we set how many rules in the knowledge base. For example, if hot, then don't touch. Okay, so this is, we can set this one lah, right? And then last component is the defuzzification lah, or defuzzifier. That means the function is to convert from fuzzy set to the crypt set. Okay, there is 4 main component that you have to remember lah for the fuzzy logic. We have the fuzzification, okay, we have the inference engine, knowledge base, and defuzzification. Okay, if you can see this one, the error here, so actually the inference engine and knowledge base is related together. So that's why you can see the error here. So that's why it will be have the relationship between the knowledge base and inference engine. That means if you do the decision on the inference engine, we have to base on the knowledge base. Okay, that's why the both will be related together. All right, so this is advantages of fuzzy. Why fuzzy logic? Okay, so you can see this is some of the advantages of fuzzy logics. Okay, so the fuzzy logic, okay, can represent vague language neutrally. For example, like I mentioned to you, near, okay, or far. So how we can set okay on the these terms into the fuzzy terms lah. For example, okay, hot, really hot, hot, warm, okay, cool. So how we can set the range? Okay, that is we cover after this. And then enrich, not replace a crypt set. Okay, we don't Okay, we don't replace the crypt set. Okay, the crypt set is the normal value lah. Okay, the normal value or classical set or sometimes we call the classical set. Okay, so and then it's allow flexible engineering design. Okay, improve model performance. Okay, compare than we use the conventional. So will be improve lah our model if you use the fuzzy logics. Okay, simple to implement and all the best and best all of all the often works. Okay, that is the advantages of fuzzy logic lah. All right, so this is a brief history of fuzzy logic. So this one I will not explain detail. Okay, just you can see here. So the fuzzy logic will be start on 1955. Okay, the fuzzy logic introduced by Prof. Lofty Zadeh. All right, and then in 1966. Okay, so you can see this one fuzzy logic by Marinos, okay, and then 72 is fuzzy measure by Sugino, okay, and then the 74 we have the fuzzy logic controller, fuzzy logic control is Mamdani lah. You can see, so that I mentioned to you on the inference engine, we have the Mamdani techniques, we have Sugino techniques, all right, so it come from this name lah, okay, the founder, the founder for example, the fuzzy measure by Sugino and the fuzzy logic control by E.H. Mamdani lah. That's why it's come from this founder lah. Okay, you can see this one. But on 1990, okay, to 1994, you can see, so government, Japanese government provide 70 million on the fuzzy research. Okay, so you can see this one. But the fuzzy logic increase, okay, a big way in the Japan. Okay, why it happened? Because if you see this one, okay, the founder of the fuzzy logic, okay, is the Europe guy. Okay, you can see the P. Marinos, Lofty Zadeh, okay, Mamdani is from Europe. So it's not from the Japan. So why it happened? Okay, one of the reason is this time the Europe guy believe on digital. Okay, believe on digital. That means 0, 1, yes or no. They don't believe on the fuzzy. Okay, they don't believe on the fuzzy. So that's why the fuzzy logic is not increased on the Europe. That's why this fuzzy will be Japan take these advantages using the fuzzy logic to improve. Okay, to develop fuzzy application in the big way lah. That's why you can see a lot of consumer product, okay, use the fuzzy logic in from Japan. Okay, that's why because of the this time they are focused on the digital. Okay, on the digital we have before this. So as you know, so digital is the normally is the 1-0 or yes or no. Okay, not fuzzy. That's why fuzzy, okay, fuzzy increase in the Japan. Japan take this technique and implement in the product in the electric appliance. Okay, so okay, you can this is you can see this one is the Prof. Mamdani lah, that I mentioned to you. That's the introduce the fuzzy logic control. All right, and then this is my Sifu, okay, my teacher, all right, in UTM. This we call Prof. Mazuki. Okay, actually the Prof. Mazuki here do on the research on this time, okay, in Japan. Okay, actually if you Google the founder, not founder, the researcher, okay, in Japan in that year, in 1990, is one of the is from Malaysia and another one from Indonesia. The both, okay, the both do the research on the fuzzy lah, and did on that time. That's why the Prof. Mazuki and another one is the Prof. Wahyudin will be famous lah on the fuzzy logic, right? So this guy is a Prof. Mazuki from UTM lah. Okay, it's the one of the researcher, okay, do the PhD in Japan. Okay, all right, so this is some applications, okay, using the fuzzy logic. Okay, you can see the Sendai subway system, okay, temperature control in the showers, air conditioners, you see the rice cooker, fridge, and so on. Okay, they use the fuzzy logics. All right, so this is some example how the fuzzy logic works lah. Okay, so you can see this one actually on the fuzzy logic based on sensor lah. Okay, we have here, we have on washing machine, we have the load sensor and we have the photo sensor lah. Okay, it actually is the our inputs. Okay, our inputs. You can see this one. If transmission is low, okay, and load is the heavy, then extend washing cycles medium. Okay, so that's why we can set range for low. Okay, for example, transmission is low, so we can set lah low from what to what. Okay, and heavy, heavy. The load is heavy, so we can set. Okay, maybe from 8 to 10 kilo is the heavy, or the medium maybe from 5 to 8 is the medium. Okay, for the loads, and then the output will be extend washing cycle medium. Okay, washing cycle medium lah. That means extend the time for the washing cycle. Okay, another example, if transmission is high, right, and load is heavy, then extend washing machine cycle longer. Okay, that's why here we normally we use that is, okay, the longer, so we can set what longer you want to set. For example, from this range to this range lah. For example, from maybe you can set for the longer, maybe from 10 minutes to 50 minutes lah, for example. Okay, so we can set based on our execution lah. That means from 10 to 15, is it clear? Is it clean or not? Uh, our okay, our ni lah. Close. Okay, is it clean or not? So we can study first. Okay, so how many cycle you want? For example, if we have a heavy load, so how many time we need to wash our clothes, for example, like that. So we can first we do the experiment and we have to study, okay, the performance, then we can do the decision lah. All right, so another example like this is we implement in our car is the Perdana 2.0. Okay, you can see we have the two sensor. Okay, we have the road first sensor is the road winding condition, and second one, okay, and the one is the sensor frequency braking. All right, so you can see this one. So example, okay, so if road is too winding and brake is applied too many times, okay, then the gear is low. All right, so this one, so this is we call the uh, linguistic variable lah. So too winding, and then another one is many times. Okay, many times, then the gear is low. Okay, or we can say as the if the road is normal, okay, and no brake is applied, then the gear is normal lah. Okay, this one we how we set our rules lah. Okay, our rules. All right, so this is some example of control paradigm. Okay, this we can see this one. We have three type of control paradigm. We have the classical. Okay, this classical maybe you study in the control class. Okay, we have the road locus, boat float. Okay, Nicholas chart, Nyquist, and so on. On the AI, we have the neuro fuzzy. Okay, neuro control, fuzzy control, genetic algorithm, and knowledge based system. And then, okay, for the modern control, we have the state feedbacks, okay, state estimation, observer, optimal control, and so on. Now, they're, for example, the researcher, they're hybrid, okay, they hybrid the modern and AI, for example, okay. For example, my PhD, I hybrid from modern to with AI lah. I hybrid with adaptive control and the fuzzy logic control lah. That is my PhD before this, okay. We just combine two classicals, okay, two technique, two design technique for the control paradigm, okay, to control our system lah. Okay, so this is some example. I think I already showed this slide. Okay, with this same. Okay, this is some example the controller that can be applied in the control system. So we have the conventional control. Okay, we have the adaptive control. Okay, we have the predictive controller. We have the intelligent controller. So also this one we can nowadays they mentioned to you the scientists. Okay, the researcher go for hybrid. Okay, go for hybrid. For example, the hybrid the PID with fuzzy, or the hybrid the adaptive controller with AI with fuzzy logic or neural controller, or the hybrid the predictive controller with AI, for example, like that. They go for more than one technique lah, not focus only the intelligent controller. They focus on more than one controller. For example, they hybrid the adaptive with intelligent, or adaptive plus predictive plus intelligent, for example. Okay, that is the example lah. Nowadays they are focus more, not only one lah. For example, like fuzzy logic, also they combine with neuro. That's why you can see on the electric appliance they use the fuzzy, and also they use the neuro lah. Okay, all right. So this is a fuzzy logic control system methodology. All right, so this is step lah. This is step how we want to design our fuzzy logics. All right, the flow chart lah, the flow chart to design our fuzzy logic controller. So the first is to study the system lah. We have to determine the objective. Okay, so identify the process, controller input and output. Okay, first we have to know lah what is our input, what is our output, and then we go for the first component is the fuzzification. So on the fuzzification, we have to set the quantize of the input and output variables. Okay, this one after we go for one by one lah. And then define the membership function. Okay, and then go for the next component is the inference. Okay, inference engine or inference mechanism. Okay, on this inference mechanism, we have to derive the fuzzy control rule base, and define the fuzzy inference engine lah. So this one you can use the Mamdani, or you can use the Sugino, or you can use the Larsen lah. Okay, that is the inference engine. And then last component is actually this inference engine related to the knowledge base lah. Okay, that's why I think the both is in the same. That's why you can see set the rules based on the knowledge base lah. And then we go for the last, okay, is the defuzzification lah. Last component on the fuzzy logic is the fuzzification. So we have to choose the fuzzification technique lah. So in our class, we focus only four defuzzification technique lah. And then we can see the simulation lah. If performance is okay, then we can end lah. If not, so we have to tune. Okay, we have to tune our fuzzy logic controller. We have to tune our fuzzy controller. Okay, so with mapping the membership function and change the fuzzy inference rule. Okay, change the rule and so on. So this one will be covered on the class lah. So after that, I will show how to design from fuzzy step by step lah. Okay, using the MATLAB on the right. So that's all for basic overview of fuzzy logic. Okay, so we will continue for the next. Okay, next topic will be on the basic of fuzzy set and fuzzy relation lah. Okay, class. I will stop here first, and then I will, because my Zoom have reminding time for 3 minutes, because of this is trial version, not the okay. If you, so I will stop here, and then I will give another link, new link. Okay, I will stop here first, then I will just give a 5 minutes. Okay, 5 minutes, and then we continue for the new topic for the basic of fuzzy. Okay, of the fuzzy logic and fuzzy relation. Okay, so we stop here first because of our meeting will be end of the 3 minutes. Okay, so I will stop here first, and then we continue. Okay, continue for the next. Okay, after this, I will share the new link. Okay, I will share the new link. All right. Okay, so maybe next time I will try the Google Meet lah. I tried the Google Meet. Before this, I also used the Google Meet. Okay, and also the Webex. Normally before this, I use the Webex. Okay, but I'm not sure why. Before this, I tried to using the Webex, so they have the videos problem. Okay, so they can see my face. So only the sound. Now they can see my face, but no sounds. I just try, so no sound. So that's why I maintain with using the Zoom lah. But don't worry. After that, I will try to another techniques. Okay, another link lah. I will try to use the Team or Google Meet or okay. All right. So this is objective for this topic. All right. So the objective is to understand the basic concept of fuzzy set, which is the basis of fuzzy logic system lah. Okay. And then second objective is to able to operate on fuzzy set using the common fuzzy operations. All right. And then understand what is the fuzzy relation. Okay. So this one fuzzy relation inside the make inference engines. All right. And the knowledge base. And then to understand how linguistic variable can be used in the fuzzy logic system. Okay, the linguistic variable that I mentioned to you, for example, like very hot, okay, warm, okay, very, okay, low. Okay, for example, how we can set the linguistic variable lah in our fuzzy logic system. And then to understand how the fuzzy rows and fuzzy knowledge base can be developed, and to understand how inference is done in the fuzzy implication, which is in fact fuzzy reasoning. Okay, at the end of this model, you should be able to operate the fuzzy logic, or sorry, the fuzzy system and fuzzy relation. Okay, so this one on the fuzzy set is inside the fuzzification, and the fuzzy relation inside the inference engine. All right. So before we know what is the fuzzy set, we have to know what is the crypt set. We have to know what is the crypt set. So you can see this one. The crypt set can be defined as the set which consists of element either full or no membership at all in the set. Okay, for example, you can see this one. All right. So if we put here, okay, if we put some point here, okay, some point here, so automatically we can get full membership. Okay, what we put here outside this, so will be 0. Okay, so that this we call the classical, okay, classical set, or sometimes we call the crypt set. Okay, so if this point, from this point, so automatically all the point inside this one will be full membership, will be 0. Okay, sorry, will be 1. Okay, the membership will be 1. Okay, so membership from 0 to 1 lah. Okay, for example, if we put here, okay, everything here, so the membership function will be 1. Okay, so outside this one and this one will be 0. Okay, so we call the classical or crypt set. Okay, all right. So what is the fuzzy set? Fuzzy set allow the element in each set have the partial membership lah. Okay, the membership from 0 to 1. Okay, and then the fuzzy set is the generalization of the ordinary set by allowing the degree or grade of the membership for each element lah. Okay, you can see this one. This is we call the fuzzy set. Okay. Okay, for example, if we put here, point here, all right, so we know. So this is, at least we have the certain partial membership. For example, here 0.4, okay? So if our point will be here, so automatically this point will be get full membership. There is this one. For example, here, we put here, so automatically we know this point will be have maybe 0.3, okay? Will be a partial membership, okay? So maybe we put here, also we can get the at least the partial membership lah. Right? Clear this one, So for example, this is we call the membership function. Okay, so this is the membership value. Okay, remember the membership value is from 0 to 1. This is standard. Okay, this is standard. That means the membership value from 0 to 1. Okay, but the difference is this one. We call the universe of discourse lah. Okay, for example, like our speed, okay, time, voltage. Okay, for example, our okay, time, for example, from 0 to 100, okay, 0 to 200 or 1000 is okay. You can set, for example, you want to set from 0 to 100. Okay, this one we call the universe of discourse. Okay, so this is we can call as the fuzzy set lah. Okay, so the common fuzzy set can the function such as a triangular, okay, trapezoidal, gaussian. Okay, so this is we call the triangular, we call the triangular membership function. Okay, so this is we call the fuzzy set, fuzzy set. So this is fuzzy set in the graphical. Okay, this one we call the graphical. In MATLAB, we use this one. Okay, so but in our class, we use numerical and graphical lah. So this one I will show the graphical. For example, for numerical, something similar like this. For example, we have fuzzy A. Okay, for example, the value of sequence 1 will, okay, so sequence 1, for example, so this is 0 0.2, 0 0.3, 3, for example, 0 0.4, 4, and so on. Okay, so this is in numerical. All right, this is numerical. Some of the book they refer to this one. Some of the book they use similar like this. Fuzzy at 1. Okay, they use the plus symbol plus. Okay, 0 0.2, use the plus 0 0.3. Okay, so this is actually is a symbol for the sequence. Okay, it's not you have to plus 0 plus 0 0.2. It's not. For example, for the fuzzy set, the symbol plus here will be just a sequence. Sequence number 1, sequence number 2, sequence number 3, sequence number 4. Okay, some of the book refer to this comma, using the comma, or some of the book refer to semicolon. Okay, some of the book. Okay, please make sure maybe you can see this one, this symbol. Okay, the plus, but the plus is just a symbol. Okay, just a symbol. It's not you have to operate, for example, 0 plus 0 0.2. It's not. It's just a symbol for the sequence, for the next sequence. For example, sequence number 1, sequence number 2, sequence number 3, and so on. Okay, this one we call the fuzzy set. Okay, fuzzy set in the numerical. Okay, this one fuzzy set in the graphical. Okay, so in the MATLAB normally we use the graphical lah. Okay, but our class we use the both the numericals and the graphicals. Okay. Okay, so this is a classical, okay, classical set theory. All right, so similar like before this, the okay, sometimes they call the clip set. Okay, you can see like this one. For example, okay, for example, this is our class. Okay, our class here. Okay, AI class. Okay, AI class. Okay, so if you sit here, okay, you sit here, so you have one membership. Okay, so for example, A, this one B, this one C. Okay, so A have one membership function, B also have one membership function, C have also one membership function. That's we call the classical. For example, D. So D guy here. Okay, D guy here. So automatically D guy equals to 0. Okay, so maybe we have another friend here. Okay, so also D we have 0. Okay, maybe we have here F almost 2. Okay, almost 2, but still we have the full membership function. Okay, that's we call the classical or crib set. Okay, clear this one. For example, like fuzzy. Okay, fuzzy. Okay, I use this. Okay, for example, this is our class. For example, this is our class. Similar like for this. This is AI class. Okay, this is me. Okay, me. Okay, all right. So this is A, student. Maybe this is student B. Okay, this is student C, for example. All right. So for example, if me, okay, the membership value is 1. For example, I set as 1. Okay, for example, the student A near to me, maybe I can set as the 0.8. Okay, at least they have the certain partial membership function lah. For example, the student B far from me, maybe we can set as the 0.5, for example. So C also far from me, maybe I can set as the 0.2, for example. Okay, that is the we call the fuzzy set. At least this student, for example, the student C have the partial membership function have the partial membership. For example, C they have the 0.2. Okay, 0.2. B they have the 0.5, and A they have the 0.8. Compare then if you use the classical. So if you use the classical, A, B, C, and me, all the we have the full membership function. Okay, 1. That is the classical. For the fuzzy, Okay, for example, I set this one, who set near to me will be 1. Okay, for example, okay. And then far from me, maybe I can set as the 0.8, 0.5, 0.2. Okay. For example, like this one. Okay, you can see this. Okay. So this is for tall lah. Okay, for example, this guy, you can see this guy will sit here. The height will be 0 membership. Okay, this guy will be 1 full membership. This is called classical crib set. Okay, compare than fuzzy. You can see on the fuzzy they use the triangular or trapezoidal or gaussian. Okay, this guy, all right, this small guy. So at least they have the partial membership function, maybe 0.4. Okay, maybe 0.2 here. And then this guy, okay, the tallest guy. So maybe they have a certain partial membership. It's not full, maybe 0.8. Okay, 0.8 here. Okay, maybe point here lah. Right, so compare this one. All right, this is between fuzzy and non-fuzzy lah. You can see if non-fuzzy, so automatically this guy is a 0 membership function and this guy automatically get a full membership function lah. Compare than fuzzy, this guy we have the partial membership function maybe 0.2 and this guy maybe 0.8. Okay, that's the difference between the fuzzy and non-fuzzy lah. Okay, this process will be happen on the fuzzification. On the fuzzification, the process that I mentioned to you is to convert from the crib set to the fuzzy set. That is the process involved in the fuzzification. So how we want to change from the crib set to the fuzzy set. Okay, so this is some example. All right, so this one I will go fast. Okay, so the set fuzzy set notation. Okay, so you can see this one. U, capital U call the universe of discourse and small u will be represented as the generic element of the U. Okay. The fuzzy set F is the universe of discourse and U, capital U is the characteristic by the membership function. Alright, so membership function that I mentioned to you from 0 to 1. Okay, that is standard lah. The membership function from 0 to 1. If you use the MATLAB, also you have to set the membership function automatically lah. On the MATLAB, still the membership function from 0 to 1. Okay, that is a fix. Okay, that is a fix for membership function fix from 0 to 1. Okay, so also this is how we can write the fuzzy set lah. Okay. All right, so when universe of discourse is continuous, the fuzzy set can be written like this lah. Okay, and then if the universe of discourse is discrete, the fuzzy set can represent as this one lah. Okay, similar like this one. So that I mentioned to you before this. Okay, so for example, like we have a fuzzy A. Okay, so you can put like this 0.1. This is membership value. Okay, this is sequence number 1, for example. Alright, so this is membership value. For example, membership value A, this is sequence. Okay, and then comma, or you can use the, okay, this one you use the symbol for add, but it's not add operation. It's just a symbol. Okay, this one just a symbol. Okay, for the next sequence. So next sequence, maybe the membership value is 0.3. Okay, sequence number 2. Okay, the sequence will be another sequence, and then let's maybe 0.5. Sequence number 3. Okay, plus 0.9. Sequence number 4. Okay, this one we can write fuzzy set in the numerical. Right, so you can use the comma here, or you can use the add here. Okay, but this add is just a symbol lah. Okay, symbol for the sequence. For example, this is sequence number 1. You can see sequence number 1, sequence number 2, and so on. So if you have 10 sequence, so until 10 lah. Okay, this is how we write our fuzzy set in numerical. In graphical, okay, you can, before this we have using the graphical Okay, so the universe of discourse, okay, defined as the collection of objects all having the same characteristic. For example, like voltage, okay, speed of car, error, temperature, and so on. Okay, this one Okay, this one we call the universe of discourse Okay, this is membership function. You have to remember this axis will be membership value from 0 to 1. All right, membership value standard fixed 0 to 1, and then this is we call the universe of discourse. Okay, and then we can set the range. Okay, this I mentioned to you. For example, this I set okay from 140 to 155. For example, 55. Okay, this range for short. Okay, this range for short. Okay, and then I set the medium 0, 50, 150 to 55. For example, okay, for example, this is range for medium. All right, for medium, and then for the tall from 160 to 175. For example, okay, this is for tall. Okay, for example, me. Okay, me maybe my height is 162. For example, okay, so point here. So I can be tall and then can be medium. Okay, for the tall, maybe my membership value is 0. For example, 0.2. And then for the medium, maybe 0.5, for example. Okay, clear this one. Right. So this one how we set the range lah. So this is based on your observation for example. So this maybe for the Asia lah. So if you put here this point, okay, you put here, for example, this point maybe 100 158, for example. So automatically this guy will be okay the medium, okay, the medium, and then the fully membership function on the medium part. Okay, for example, the example for me, for example here, so maybe you can set as the tall, okay, but the tall, the membership function maybe 0.2, or another one will be okay medium, okay, medium maybe 0.5. So we can choose either you want to select the medium or you want to select the tall. This one we have to decide lah after this. Okay, we have to decide we want to select for 0.5 or 0.2, 0.2 for tall or 0.5 for medium, for example. Okay, so you have to remember the membership. This is we call the membership value. This one, this the graphical. Okay, this one we call the graphical. All right, so you have to remember. So this one is the membership value from 0 to 1, and then this is universe of discourse. Okay, this depend. Okay, maybe you can this one, for example, the universe of discourse is the height. Okay, for example, your system depends. You want to do a kilometer the speed. Okay, maybe you can set speed from 0 to 100 kilometer per hour, for example. Okay, and then you can set the membership function for slow, for fast, for medium. Okay, that is how we set on the fuzzy membership lah. Okay, this one we have the 3 membership function. We have short, we have the medium, and we have the tall. Okay, so for example, the tall we have the range lah. We have the range from 160 to 75, and then for medium we have the range from 150 to 165, for example, and then for range short, okay, for short we have the 140 to 155. Okay, for example. Okay, this is we have 3 membership function. Okay, this is maybe you can set as the fuzzy short. Okay, and then this is fuzzy set for medium. So this is fuzzy set for tall, for example. Okay, so this one in the graphical. Okay, you can see this one we call the in the graphical membership function. Okay, so we go for the basic fuzzy operation. So this is, we have 4 basic fuzzy set. Okay, operation. There is equality. That means fuzzy set A equal to B. That means everything A will be similar like B lah. For example, fuzzy A. Okay, we have 0.1 is equal to 1, 0.9 to 0.3. For example, all right. So if you use the equality, that means fuzzy set B will be same lah, 0.1, 1, 0.9, 2, 0.3, that's equal number 3, right? If we do the complement, for example, the complement of fuzzy set A, Okay, if the complement, you can see this one, the operation is 1 minus fuzzy set A. For example, complement of fuzzy set A. All right, so that means the complement, we call the like this for complement. Okay, so 1 minus 0 0.1. Okay, there's 0 0.91. Okay, next 1 minus 0 0.9, 0 0.1 sequence number 2. And then next 1 minus 0 0.3, so 0 0.7 out of sequence number 3. Okay, that's we call the complement of fuzzy set A. Okay, clear this one, eh? So just minus with 1. For example, 1 minus 0 0.1, we get 0 0.9. 1 minus 0 0.9, we get 0 0.1. 1 minus 0 0.3, we get 0 0.7. Okay, every sequence you have to add with minus with 1. Okay, minus with 1. Okay, clear this one, eh? Okay, and then for intersection, okay, for intersection, the operation is the and we have to select the minimum. Okay, minimum, for example, minimum. Okay, I will show some example. So here, fuzzy set A, and then we do the new fuzzy set B, maybe 0 0.5, sequence number 1, 0 0.7, sequence number 2, 0 0.3, sequence number 3. Okay, so we have to compare, okay, the fuzzy set for intersection A, intersection with B, select the minimum. So we have to compare 0 0.1 and 0 0.1, 0 0.5. Which one the minimum? Is the 0 0.1. Okay, sequence number 1. Okay, next, sequence number 2, 0 0.9 and 0 0.7. Which one the minimum? Is the 0 0.7, sequence number 2. Alright, and then sequence number 3, 0 0.3 and 0 0.3 is the same. So maybe 0 0.3. Okay, clear this guy? Clear. All right, so this is for intersection operation class. Okay, for next we go for union. The operation is OR. So here we have to select the max. Okay, select the max. For example, F, sorry, say A union with B. Okay, we have to select the minimum. Sorry, the maximum, 0 0.1 and 0 0.5. So the maximum is the 0 0.5, sequence number 1. Okay, and then second sequence 0 0.9 and 0 0.7. So the maximum is the 0 0.9, sequence number 2. And then sequence number 3, 0 0.3, 0 0.3 will be same. So the answer is the 0 0.3, sequence number 3. All right, so this is how we do the operation. Very simple, straightforward. For the fuzzy set operation, this is a basic fuzzy set operation lah. Very straightforward lah. For example, equality, if the fuzzy set A equal to B, that means all everything fuzzy set A will be similar like B lah. For example, like this. Okay, for complement, so complement of A, that means everything you have minus with 1 lah. For example, sequence number 1, 1 minus 0 0.1. Okay, 0 0.9, 1 minus 0 0.9, 0 0.1, 1 minus 0 0.3, 0 0.7. That is for sequence number 3. Okay, for the intersection operation, we have to select the minimum. Okay, we have to, the operation is the, we have to select the minimum here. Okay, the minimum. So minimum, we have to compare, make sure compare the same sequence lah. Okay, sequence number 1 and sequence number 1. You cannot compare sequence number 1 and sequence number 2. Alright, for example, you have to compare sequence number 1, 0 0.1 and 0 0.5. Which one the minimum? The answer is the 0 0.1 lah, minimum. And then second sequence 0 0.9, 0 0.7. So the minimum is 0 0.7. Okay, and then 0 0.3, 0 0.3 the same. So that's why the answer is 0 0.3. Okay, that is for intersection. All right, so for union, you have to select the maximum. The operation, you have to select the maximum. So for example, you have to compare the same sequence, 0 0.1 and 0 0.5. So the maximum is 0 0.5. Okay, and then 0 0.9, 0 0.7. So the maximum is 0 0.9. Okay, and then 0 0.3 and 0 0.3. So the maximum is same, 0 0.3. Okay, that is the operation on the fuzzy set. Okay. right? So this is other fuzzy set properties. Okay, this one. All right. So the membership function, okay, so that I mentioned to you, we can define as the numerical or functional, or some before this, another one is the graphical lah. Okay, so this one we call the numerical. Okay, that I mentioned to you. This is, for example, 0.1 sequence number 2. Okay, for example, if you get like this, okay, so actually we have, okay, suppose we have like this. Okay, sequence number 1 is 0. Sorry, 0, sequence number 1. Okay, and then plus 0.1, 2, plus 0.3, 0.4, sequence number 3, and so on. Alright, you can see this one. So if the sequence not appear here, so automatically the membership value is 0. Okay, for example here, sequence number, we start with sequence number 2. That means sequence number 1 will be 0. Okay, sequence number 1 will be 0. And then 6, 7, 8. Okay, the rest is okay lah. So this one we call the numerical. Please make sure. So this is for symbol. The add is for symbol lah. It's not for operation. The simple kali mistake that previous student, the previous student, okay, they add this. Okay, this. For example, 0.1 plus 0.4 plus 0. No, that is for sequence. This one for numerical, just for symbol. Okay, this add for the symbol lah. Maybe you can put as the comma, okay, or semicolon. Up to you lah. Which one you are familiar lah. So normally some example they use the add. Okay, add. This one this is for symbol lah, not for add operation. Okay, and another one is the functional lah. Okay, the functional. Normally in our class we just use two numerical or graphical. Okay, so another one you can use a functional lah. Functional more involve power, more power lah. Power, for example, power of more than power of 2 lah. Okay. Okay, so this is some example. You can see this one. Some example for the using the graphical. Using the graphicals. Okay. So normally in our class we just focus on the triangular and trapezoidal lah. Okay. So because of what? Because of the when you do the programming. Okay. Before this they use the programming because involve of y equals to mx plus c. Okay, just a linear equation. But if you want to use the, for example, like Gaussian, okay, the exponential, the p function, f function that involve power lah, more power of something, so involve of non-linear, okay, non-linear equation. Okay, so that's why in our class we just focus on the triangular and trapezoidal, because when if you want to do the programming on our fuzzy logic, before this they use the programming, but now no need to use the programming, just use the MATLAB. Okay, use the MATLAB, automatically will be do for the fuzzy logic lah. Before this they use the algorithm. They use the algorithm to design the fuzzy logic lah. That's why I mentioned to you they use only the triangular and trapezoidal, because only involve the linear equation. Okay, so this is a trapezoidal membership function. Okay, this I will just explain this one. For example, okay, for example, this one is the zero membership. Is a zero membership function. Okay, so this part, okay, assume you put here some value here. Okay, for example, I put here as a u. Okay, so automatically you know u minus alpha divide by beta minus alpha. All right. Okay, that is equation. Equation to get the membership value here. All right. So you put some u here. Okay, the equation will be u minus alpha divide by beta minus alpha. Okay, that's his equation for this membership value. Okay, for this part. Okay, for this part. All right. So you put some here u. Okay, the equation is the gamma minus u divide by gamma minus alpha. This beta, right? Similar like this. Okay, make sure this is in positive. Okay, the membership value is the positive, from 0 to 1. That's why suppose this one, the equation should be negative, but because we want to calculate the membership, okay, membership value. So that's why this one in the positive lah. So that's why this point, okay, minus with u, divide by this point minus this point lah. Okay, for example, like this one, I put here. Okay, so put here as a u. So automatically we know u minus a divide by b minus a. Okay, that is the answer lah. You can see this one, All right, for example, like this one, For example, we put here some u. Okay, so the equation will be like this. C minus u divide by C minus b. Okay, so this one will be in the positive value. Okay, positive value. Okay, this one also positive value. Okay, clear this one, All right, so this one will be important when you do on the defuzzification after this, on the last component on the fuzzy logic. Okay, this one, this equation, Okay, this equation will be used on the defuzzification, on the defuzzification. So how to get the equation for this one? Using this one, you put some value here, all right, u, and then this value, okay, minus with alpha, divide by this value beta minus alpha, all right. So this is to get this equation, And then for this equation, okay, so for normal equation is the negative, but in our fuzzy logic, we don't use the negative because the value from 0 to 1 is the positive. That's why you have to use the positive, okay? This minus with u divide by this point minus with this point. Okay, yeah. All right. So for example, okay. So this is for membership function. I skip this one because this is involved of power of 2. Okay. Normal in our class, we just focus on the triangular and the trapezoidal. All right. Okay. So for example, this one, For example, from this point to this point, so the membership value is 1. Right. Okay. From this point, okay, for example, I put here u. All right. So beta minus u divide by beta minus alpha. Okay, this for this equation. And then the range from beta to inilah alpha. Okay, this u. So not like this. Okay, so this is alpha, this is u. Okay, this is beta. Okay. All right. For example, like this, Okay, this equation. All right. So we put some value here. We put some x lah, We put some x. So we know this equation x, okay, minus 1, all right, divide by 2 minus 1. Okay, that's for this equation. So that means x plus 1, okay, divide by 3, for example, Okay, for this equation. And then for this equation, all right, so we put some x here, okay, 5 minus 3 divide by 5 minus 4.
Kalau kau bungkus
Okay,
ni tak
so
payah. Kalau kau pakai bungkusan dia kena
we have the equation here lah. So that means the equation will be 5 minus x. Okay, 5 minus x because 4 minus 1 will be 5 minus 4 will be 1 lah. Okay, this one will be 1. So that is for equation lah. Equation for this part. Okay.
என்ன சாஃப்ட்வேர் பச்சிங்க எரியறதுக்கு இல்ல போன்லயே இருந்தீங்களா இல்ல லேப்டாப்ல இருந்தீங்களா?
Okay, yeah, this guy. All right, so I will stop here. So next week we continue on the next fuzzy operation. Okay. Any questions so far? Guys, any question? Okay. So how to get?
Sir, okay.
Okay, doctor.
Okay, I will stop here first. Okay, so maybe next we continue on topic number 1.2 lah, the fuzzy set operation lah. I think this for you can see the fuzzy set operation is similar like before I explained before this lah. Okay, for example, you can see this one. Okay, the operation will be same. So if union, that means we have to select the maximum. If the intersection, we have to select the minimum. Okay, the complement we have to minus 1 lah for complement for A and so on. Okay, This one will be covered for next week lah. Okay, so if no question, I will stop here. So we continue for next week. Okay. At the same time, you can try to tutorial one. You can try to do the tutorial one. Okay. If you have any question, you can ask in the group. Don't worry. Okay. So if not, I stop here. So thank you very much and assalamualaikum warahmatullahi wabarakatuh.